In the next topic, we're going to learn 3 different ways of evaluating expressions. What I mean by that is that we're going to be substituting numbers for variables and coming to a numeric answer. So let's first take this first example. Find the value of 2 times the quantity p minus 4 plus p squared for each of the following. Let's evaluate it first at a positive number, so when p equals 5. We get 2 times 5 minus 4, notice I'm substituting 5 for p, plus 5 squared. I'm going to use my order of operations to simplify this. So my first step is going to be my parentheses. So I'm going to get this to equal 2 times 5 minus 4, which is 1, plus 5 squared. Next order of operations is my exponents. So I get 2 times 1 still, plus 25. My next order of operations is multiplication and division. So here I have some multiplication between the 2 and the 1, which is 2. And I carry down my plus 25. And my last step is going to be my addition. 2 plus 25 is 27, and that is our answer. Now let's evaluate this at a negative number. Let's try p equals negative 2. I'm going to copy down my expression before, except now I'm going to use negative 2 for p instead of 5 for p. Now notice I used parentheses whenever I'm substituting for an exponent. That will come into play in one more step. So let's start with our order of operations. Our first step is going to be to simplify the parentheses again. Negative 2 minus 4 is negative 6. Now, to save some space, I'm also going to evaluate my exponents. Negative 2 squared means negative 2 times negative 2. And if you recall, a negative times a negative is a positive. So my key here is that this actually equals positive, not 2, positive 4. And I'm writing this in orange because positive 4 is what we get from a negative squared. Now if you type this in your calculator without the parentheses, you're going to get negative 4, which is incorrect. Our next order of operations here is multiplication. So 2 times negative 6 is negative 12. I'm going to carry down my plus 4. And now finally, negative 12 plus 4 gives me negative 8. The second type of expression we're going to be evaluating is actually called a function, where x is what's called our input. We're going to plug a value in for x, and that's going to give us our f of x, which is our output. So I'm going to evaluate my function at f of 4. What I'm going to do is I'm going to substitute. Now 4 is my input. That's going to substitute in for my x whenever I see my x. So using my order of operations, my exponents come first. So I carry down my 5. 4 squared is 16 minus 7 times 4. My next order of operations is my multiplication. So I can do both steps of multiplication. 5 times 16 gives me 80. Negative 7 times 4 gives me negative 28. And lastly, 80 minus 28 gives me 52. Like before, let's also evaluate this at a negative value. So let's try f of negative 1. So my f of negative 1 is going to equal 5 times negative 1 squared minus 7 times negative 1. Notice I plugged in negative 1 for x. Well, negative 1 squared, a negative times a negative, is a positive. So I get 5 times positive 1. And negative 7 times negative 1 is going to give me positive 7. So notice how that changed from subtraction to addition. Next step is my multiplication. 5 times 1 is 5. I'm going to carry down my plus 7. And lastly, 5 plus 7 gives me 12. A harder function that we might see occasionally is when there are two inputs. So here, I'm going to determine g of x comma y equals 7x minus 3y plus xy. We're going to find the values when g of 5 comma 2, where 5 is going to be my x and 2 is going to be my y. So I'm going to now rewrite my function with 5 substituting for x and 2 substituting for y. I'm going to evaluate all of my multiplication at the same time. So I get 7 times 5, which is 35. Negative 3 times 2 gives me negative 6. And 5 times 2 is positive 10. I evaluate my subtraction and addition from left to right. So 35 minus 6 is 29. Plus 10 gives me 39. The last types of expressions and equations we're going to see is when we're talking about mathematical formulas. So here, the area of a circle can be found using the formula A equals pi r squared. We're going to determine the area of a circle with a radius of 6, so r is going to equal 6. What I'm simply going to do is I'm going to use my formula, and I'm going to plug in 6 where I see my r. I'm going to evaluate my exponents. 6 squared is 36, and I always write the number in front of pi. So 36 pi. This is what's called our exact answer. Most times we're going to be asking for the exact answer, or leaving it in terms of pi. But occasionally we might ask you to round. In that case, we're going to want to type this into our calculator. Always use the pi button, and you're going to get 113, and in this case, let's round to the nearest thousandth. So we get 113.097, and we're going to use our, notice over here in green, we're going to use our units, and we're talking about area, so it's going to be inches squared. So this is the rounded answer, while 36 pi inches squared is our exact answer. Here we have one more example of a mathematical formula. Let's take a look. The volume of a rectangular prism is given by the formula V equals 1/3 area of the base times the height. Here is a rectangular prism with a length of 6, a width of 4, and the height of 9. Now, these are the three things we're going to be substituting in, the length, the width, and the height. But we're given the area of the base. If we take a look at this, the base, and the fact that it's a rectangular prism, we know that it's going to be a base, or a rectangle. So, let's rewrite our volume formula. Volume equals 1/3, well, the base is going to be length times width, the area of the rectangle, times the height. Now let's substitute our values that we know. L is 6, W is 4, and the height H is 9. So now I'm going to multiply this all out. 1/3 times 6 is going to give me 2. Carry everything else down. 2 times 4 is going to give me 8. And 8 times 9, whoops, that shifted, is going to give me 72. And we're talking about centimeters cubed. And there we go.